So we talked about one aspect of the distribution of a quantitative variable was its shape. Another aspect has to do with the actual values that are underneath that histogram. All right. So one question we might ask is, what's a typical value? All right. So one of the examples we used was that list of hybrids. So we might want to know what's a typical price, or what's a typical year range, and what's a typical mileage for those cars that I picked out. And so I want to know an average. But what is going on in the middle of that distribution? There are two measures of center that we tend to use in statistics a lot. One of them is the median, and the other is called the mean. The median has to do with counts. The median says, okay, let's count all the observations. I want half of those observations to be less than the median, half to be greater. So it's called the middle value. So here it's going to have half of the values are going to be less than, and half of the values, half of the counts are going to be greater than that median. So how do I go about doing that? So the first thing I would do is I would sort the list from smallest to largest. So if you look here, these are the list of mileages. So what I did is I went ahead and just to simplify the calculation, I rounded these to the nearest 1,000 miles. StatCrunch will sort these for me. So if I come over here, it says I can sort the table ascending, and it will sort. So you can see there's 47, 65. So it sorts the list for me. And I've got these 20 values, and that is what I have right here. So I got 47, 65, 60, okay, etc. And I want to find the median of this list. So I sorted the list. The median happens to be the n plus 1 over 2th observation. All right, so I've got n equals 20 cars. All right, so if I add 1 and divide by 2, so 20 plus 1 over 2, if, all right, so it's 21 over 2. 21 over 2 is 10 and a half. So the median is either that observation, or if it's in the middle, it's going to be between the 10th and the 11th observation. So here, the median, this is going to be the 10th observation plus the 11th observation divided by 2. So it's halfway between there. So if I count, and there's 20, so now I got 10 up here, but I got 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 10th, and this is the 11th observation. So 10th plus 11, so this is going to be 83 plus 84 divided by 2, which is 83,500 miles. So the interpretation for this, remember, okay, this is the median, is 83,500 miles. So what this tells me is that half of the cars in my data set, have fewer than 83,500 miles. And half of the cars have over 83,500 miles. All right, so I have a histogram I made here, and that red line is the median itself. That's the 83.5 marked on there. Now recall the area principle, that the counts are proportional to the area in the graph. So what that tells me, so since half of the count is less than the median, half the count is bigger than the median, then approximately half of the area of the graph will be on the left side. So we're going to have about half of the area over here and half of the area over here and on the right. we have one more property of the median, which is a very powerful property. And this is that the median is resistant to outliers. So in our graph over here, if we look at this last point, we said that was a potential outlier. It's kind of a high measure of mileage. Now, if I remove that point, I said, well, I don't want that big one in there. It's a little bit too big. I'm going to throw it out. It is not going to change the value of the median that much, because removing an outlier, even if it's an extreme outlier, even if that was 300,000 miles, if it's some crazy mileage, removing an outlier in this particular data set would just shift the median from, right now it was between the 10th and 11th observation, to just being equal to, let's see, to just being equal to the 10th observation. So removing a number isn't, removing any value is just going to shift the median by half a value. And so I have lots of data points that are in this area. So the median is not going to change much. And that's great, because it means from sample to sample, the median is going to be consistent. So even if I had a really big outlier, it's not going to affect the median that much. So that's a really good thing. So we want to use the median anytime we have data that is very skewed or has extreme outliers, or an extreme outlier. Now this graph does not have either. This is not very skewed, and this is not an extreme outlier. So I could use other measures of center. But if I did have extreme outliers, or I did have extreme skewness, then this is the center that would be the best one.